Greetings from New York City and welcome to Candid with Index. I'm Sarah Cannon, a partner at Index Ventures, usually based in San Francisco, but very happy to be in Grid.ai's offices in New York City today with William Falcon, who is our guest. William is the co-founder of Grid.ai. Welcome. Thank you for joining us.
Thank you, Sarah.
So first question for you is, you were born in Venezuela, which is not often for founders I get to meet. Would love to hear about how your family ended up in the United States and how being from Venezuela influences how you see the world.
In, I think, late 90s, we somehow ended up entering the lottery for the green card. So I think my uncle was studying here at Georgetown and decided to enter, my immediate family for it. And we randomly got it. And so instead of doing one of these moves where you kind of come here for a bit and then go back, we ended up just fully moving here, right? So basically starting all over from scratch, which was, both my parents are professionals, but here they didn't know any English, they didn't know anything about the culture or anything else. And so it was basically starting from zero. And yeah, that was just a very, very interesting time frame, I guess.
And how do you think that's made you see the US or your work differently from someone who was born here?
I think when you live in a place where you're outside of the system, it's not clear to you that you're outside of it until you see people in the system, and then you realize all the things that are not available to you. And so I think that's made me be more open about the opportunities and things that are possible that I may not be immediately in my own view, I guess.
One of the things that really stood out to me when I first met you was the kind of unconventional journey you took to being a founder, not only being from Venezuela, but also pursuing SEAL training. So can you tell us a little bit about why you decided to join the US military and what that experience was like?
1 year in high school, I went to a sea and air show in Florida. And then I saw these guys jumping out of helicopters, and then they swam to the beach and they did a mock takeover of the beach. And I was like, oh, that's really cool. And they're like, oh, these are SEALs. I was like, oh, great. How do I do that? And they're like, well, you're not going to because no one does it, right? And I was like, okay, interesting. So I spent basically the majority of high school training for that, running and swimming and trying to get in shape for that. And I think the more people told me this is impossible, you won't ever do it or get in, it made me want to do it more. And I eventually ended up applying and got accepted to it and kind of shipped off, I guess. Growing up in Venezuela, you're surrounded by the drug trade and kidnappings and violence, and it's everywhere. So it's just kind of growing up in a sort of war zone, I guess. But it happens to your family, it happens to your friends. So it's just nature. And, to me, it was I want to be there on the front lines, because when it comes down to making a decision about something that may be controversial or not, I trust my own ability to make that judgment. And so for me, it's really about being at the right place at the right time to have impact. At that moment, that was probably the closest thing that, given my current life circumstances, how I could have the most impact.
And you talked about growing up in a war zone and then being on the front lines, and then you ended up studying math, which could be viewed as a little bit orthogonal, or maybe that's the front lines of a different variety. And you found a love for machine learning. Can you tell us a little bit about how you fell into that?
So when I got to school and they were like, hey, look, you got to take calc and all these different things, I was like, great, I haven't been great at math, this is not going to be good. And then I failed my first calc test, right? And I got a 20. And everyone was like, no, you got to drop this class, it's not going to work for you. And I was like, I don't know, I just came out of this whole thing, I'm sure I can figure this out. So I remember I just bought the calculus book and just read it page to page and did every single practice problem and ended up getting an A+. And then after that, calc was easy. I don't know how. I think I just studied a lot, but it was just a function of effort and put in the time. And so I don't think to this day there hasn't been anything where I've been wrong on that, where it's hard, I fail at it, and then I'm no, it's just effort. I put in the effort and I get it done. And I think that's probably why I've gravitated towards math, because the challenges in math are very, very difficult. And it's not something that I'll ever be able to master or know deeply. And I think research and PhD was that, because it's I want to be in a place where, the problems are so hard and open that no one knows, that you may never know, but it's a better place than doing repetitive work over and over again that you can actually solve, right?
Well, there are clear themes of determination and going after the impossible. When you think about your philosophy, is there a friend or a thinker that has most influenced kind of how you think about the world?
We read a lot of like Marcus Aurelius while we were going through training. And I mean, there was this amazing Master Chief, Will Guild, who like taught us a lot of mental toughness in training. And probably, I mean, like as an adult, I think I grew up a lot in SEAL training and like in like that environment. And so I think a lot of what he said probably influenced me. But it's specifically around handling like your own internal conflicts and like the way that you approach things. And, there are some mental toughness techniques that are taught to everyone who's going through that. And I guess I apply those a lot.
And over to your work life, you founded an open source project called PyTorch Lightning when you were at Facebook's AI lab. Can you explain to people who may not know what PyTorch Lightning is and how it came about?
When I started at NYU, I had just come off my previous startup, which had been acquired. And so I've been putting AI in production for like years. And so I knew like the tricks and things that people needed to do. And then I got into a research world where I was like, okay, now I know what things researchers need to do as well. And so I was like, how do I move fast through research, having that like startup mentality as well of like move fast and like iterate on things quickly, right? Because at the end of the day, like research and building companies have a lot of similarities, which is like this rapid iteration process of finding a solution to something, right? And being like systematic about how you do that. And so Lightning was my internal tooling to help me move through that quickly. And so I spent the first few months building that. And then when I got to Facebook, it was like, you have all this compute, how do you scale that up? And so I ended up like making Lightning way, way more robust, from like a small side project to something that people at Fair could use, and then eventually people at Facebook. And then it just kind of took off. Like I wasn't planning on it being anything more than like something that a few of us would use. And it turned out to be super useful for a lot of people. And so I think it ended up forcing me to spend like, I think half of my PhD at this point is just Lightning, because like that's pretty much all I did. And I'm very thankful to my advisors for giving me the time to do that. But it allowed me to basically focus on like build something now that is so general that you can do any kind of research with. And when you're done with that research, you can deploy it and productionize it without doing any work.
It sounds like the adoption at the beginning was even surprising to you. It certainly was impressive to us. But now there is a real scaled community, even with people all over the world using Lightning. Can you tell us a little bit about that community today and the characteristics of it and what that experience has been like?
I was definitely shocked. I mean, I was expecting maybe a few people to use this and be happy with it. And it's turned out to be thousands of people, right? All over the world doing all sorts of crazy things. And then I think what's also shocked me is like the flexibility of all this. And the people in that community have built that flexibility in, right? So you have people who are data scientists, who are machine learning engineers, who are AI researchers, who are PhD students, people at the top of their fields doing all sorts of research, right? If you want to train a transformer on thousands of GPUs, like you need to have certain know-how that you have to build into that framework. And so these members of the community build that into the framework so that when a machine learning engineer or data scientist wants to do the same, they don't have to be a fair research scientist to know how to do this. I guess I like to think about it as like your research lab and like your coding buddy, where like normally people work isolated and they would have done the same work individually, where like maybe I built TPU training on my own code, but now I can do it with Lightning and suddenly thousands of other people can benefit from it. So it's like a really cool social project as well.
Absolutely. And then you decided to turn it into a company, Grid.ai. So can you tell us about when you decided to found a company around Lightning and how you met your co-founder, Luis Capello?
If you think about the problem of like research to production, Lightning is actually solving a lot of those problems, even though we may not have built it for it initially, but people have added things to it and taken it in such a way that it now is doing that. And so, but there turns out there's this whole other cluster of problems that Lightning cannot solve. And that itself sounds like very hard to do in another open source project. So how do we get that done, right? I have a friend, Louis, who's my co-founder, and I'd met Louis years ago. He was doing a bunch of NLP stuff at Force, building a lot of their products, and I was running my other startup. And we've been like intellectual friends. We would engage and talk about the latest research and like how it could be applied. And I was like, Louis, you have a lot of experience putting things into production at like bigger scales, right? So how about we partner and like we basically make this behavior and everything else that's missing from Lightning and put it into this other product, right? And so we ended up thinking about Grid.ai as a way for people to be able to scale up beyond what's available in the open source and get a lot of value specifically for their users or clients and build products with them, right? And that's what a lot of Grid AI is. It's like the things that Lightning can't do that are just really annoying to do on your own and like really difficult as well.
You had said at the beginning that you liked math because of the complexity and some of it has kind of remains unsolved. So if you look at machine learning, what unsolved problem is most intriguing to you?
I think a really interesting direction is to figure out how to not make it so expensive, right? So on the self-supervised learning side, that means not using so many, like, it's called negative samples, right? Where I say, this image is similar to this, but not similar to these other things. And those other things are negative samples. And that process is very expensive. So how to get rid of that comparison, right? So that will lower the cost of training these models dramatically. On the industry side is that a lot of the stuff that is interesting is now coming out of research and like is now prime time ready to be adopted for deep learning, right? And I think initially the industry grew like a really unhealthy like distrust for deep learning, because what happened was, 2015, 2016, some data scientists found out about neural networks. They looked them up, then they spent 6 months trying to get them to work. They didn't work. Then they tried a random forest, spent an hour, got it to work. And they're like, well, 6 months didn't yield me better results. And that's true back then, but now the tooling is such where, getting that extra 1 or 2 incremental percentage of accuracy is actually only going to take you a few hours. And so now I think we're gonna start to see a world where like a lot of these more traditional models are going to start being replaced by neural networks. And at the end of the day, a lot of these traditional models can also be framed as deep models, right? So like linear regression, logistic regression, and even like approximating like a random forest, like these things can be kind of like coded up in a neural network way so that you can leverage multi-GPU training, multiple TPU training, so you can get better hardware out of it as well.
We talked a little bit about how, when you were building Grid, AI could be used for a lot of things, and you wanted employees that would test you and say, I don't want it to be used for this, or let's have a discussion about it. Where do you think AI will have the biggest impact on society, and maybe a positive? Let's pick a positive case.
I think real-time translation is probably one of the things that AI can excel at. Specifically because for real-time translation, so when do you want to use neural networks on deep learning is anytime you have like some sort of like natural input, like an image or sound or text or something like that, right? And that's when they tend to work better. So speech is one of the best, like no model is going to be better than a neural network.
I mean, I'm like thinking, could this improve diplomacy, right? Because so much of this, like you go to these UN conferences and there is a delay, it's like very hard to communicate with another person. And if that's sped up, like does that increase the quality of conversation and outcomes?
And I think like, one criticism of that is like when you're having meetings, like being able to translate something may not capture the emotions and semantics behind that. And so I think that the next set of tooling from the AI side is going to be like, how do you style transfer like emotions? How do you style transfer like I don't know, empathy, right? To be able to understand, so when I translate, it doesn't sound robotic, but it actually carries across the meaning that I was trying to get at, right? Because that's something that humans excel at is like, if I were to speak to you in Spanish, like I can tell you something I can say the same exact words, but I can say them in a different way that I can convince you, whereas a pure translation may not be able to do that.
Maybe to think about advice for other people who are starting companies. So we're in the early days of Grid.ai. Are there things that already, though, you've learned that you wish you'd done differently? Or if you could tell yourself a year ago when you were just getting started that you wish you'd known?
I think the main thing is just like, not try to fit, like don't come up with a product and then try to fit that somewhere. I think it's about identifying people who care about something and then building something around for that person, right? And I think Lightning is a good example of this where, a lot of the stuff that's in Lightning today was not stuff I thought about for sure. It's stuff that people in the community put in, and it's solving their problems, right? And so less about, here's a thing I care about, I'm gonna try to like fit it into the world, and more about, okay, who cares about something and like what can I build for them to solve that problem? And is that problem interesting enough for anyone to care about? Build something that people care about and then go raise money. Because like maybe the way I thought about it is like, I could spend 6 months trying to fundraise and like an idea that it's not proven and maybe not get anywhere instead of like spending 6 months building it and then spending a few weeks fundraising, right? Like it's just a lot easier.
You made it much easier for us, thank you. And what's next for you and for Grid?
So I think today for us, like our broad goal is to make it so that a machine learning engineer, data scientist, or researcher can focus on the like actual work of building the models and like testing those models as opposed to like putting them into production and doing any kind of work. And I think the long-term vision that I like to see is that the person who builds the model, the researcher, is also the person who like does the deployment and does the thing and like gets the feedback, right? Because at the end of the day, like what happens today is you have someone who builds the model, a researcher, machine learning engineer, whatever, and then a whole set of other people who put that stuff into production to do what? To get feedback to see if that thing worked, right? And then once I get that feedback, then the model builder goes back and changes it and does that. But there's this whole like stuff that happens here that none of that needs to be involved. So ideally it's like letting the driver be the person who like has all of the information and like can make all of the changes. And so it really comes down to empowering those people to have full autonomy and like control of that whole process. And I think that's probably what we're getting at.
It's also back to the core idea you mentioned of accessibility, right? That it's actually making that entire process accessible to that one person and making it for more people rather than someone who necessarily had all of that skill set, by themselves at the beginning.
Yeah, like we want to democratize it and make that access easier so that the people who end up on okay, I need to solve a problem, don't have to be an expert machine learning engineer, don't have to be an expert researcher, but can just say, okay, well, here are the solutions that are available to me to solve that problem. And I'm going to use Grid or Lightning to make that happen in like a few hours instead of months, right? So in my ideal world, a paper comes out tomorrow, and within half a day, like half of the industries in the world are using that latest work.
Cutting edge for everybody. Thank you, Will, very much for sharing. Even I got to know you better and some of these kind of original life experiences that have shaped kind of the products that you've built and how you're building the company. So we have a fun game that we're gonna play. My sisters actually don't like to play games with me because they say I never lose, but given what I knew about you and then what I've learned about you today, I have to say I'm a little intimidated. It's also a machine learning Jeopardy, so I feel ill-matched for this game, but are you ready to do it?
Let's do it, yeah.
And the prize is this elegant trophy. I'm told it's all gold, actually plastic gold. This is what we're fighting for, and as a guest at your office, I am happy to have you ask me the questions first. So here we go.
So question number 1 is a mathematical formula for determining conditional probability. It's a famous one, very famous.
Bayesian probabilities?
Close, yeah. Who's the
Conditional
guy?
probability?
No, that's great. I'll let that slide. So Bayes' theorem. So
okay,
yeah.
We're close.
So we're close. Nice. We'll give this one to Sarah. So a branch of computer science dealing with the simulation of intelligent behaviors in computers.
Artificial intelligence?
I hope so. Nice. That's a good one. All right. So the phenomena of observing results that are systematically prejudices due to faulty assumptions.
Bias?
Yes. Nice. Great. Wow. Crushing it. All right. Setting the bar high. Okay. A method, function, or series of instructions used to generate a machine learning model.
Algorithm?
Yeah. Nice. Algorithm.
There we go.
Okay. Man, you're crushing it. Okay. No pressure. The act of making predictions outside the range of a data set.
Ooh, external validity?
It's close. We can give you that one. Extrapolation. Okay, so a measure of how tightly packed your predictions are for a particular sample relative to one another.
A measure of how tightly packed your predictions are.
Yeah, so if you were to like test like SAT or something,
yeah,
and then you have like a mean score or median, right?
Yeah.
Then the numbers around that, like what do they give you?
Standard deviation.
Right, and then what is the square? What is it? The square root of that? No, sorry, variance is the square root of standard.
Of variance.
Yeah, there we go. A data point that deviates significantly from
an outlier.
Nice. Outlier.
There we go.
All right. Another term for false positives.
I don't know what this is.
Okay, it's going to be type something. Type 1 or 2?
Type 2 problem? Type 1 error.
Nice. Okay, a set of data used to generate machine learning models.
A training set?
Yeah, there you go. Any irrelevant information or randomness in a data set which obscures the underlying pattern.
Noise.
Yeah, nice. Filtering for noise. All right, that's pretty good results.
Here we go. You ready? The negative effect that occurs when the model builds an assumption from an insufficient amount of data.
I guess this is underfitting probably, or overfitting.
Close.
Overfitting.
Overfitting. Exactly. Well, you definitely gave me 2 chances, so I'm giving you that one. Okay. A type of neural network designed to process data with sequential nature, such as text or stock prices.
RNN, but I think colloquially people use LSTM or GRU specifically.
Exactly, recurrent neural network. And he went, I think he gets extra credit by giving 2 others. The center of a cluster as determined by a k-means or k-median algorithm.
Oh, centroid.
Man, feeling really great about this investment. All right, in the context of binary classification, the measure of the model's performance at classifying positive observations.
It's like precision, a recall.
Yep. All right, the restriction of the values of weights in regression to avoid overfitting and improve computation speed.
Normalization?
Exactly. All right, a description for the number of times the algorithm sees the entire data set.
An epoch is a whole loop through a data set. So training epochs, there you go.
A wide family of machine learning models that mimic the behavior of a human brain when processing data.
I would say that neural networks, which is the answer,
Yep.
are not strictly trying to mimic human brain, but they're inspired by the human brain.
As a metaphor, a family of machine learning models that teach themselves by example.
Supervised?
Okay.
Yeah, that makes sense.
The process by which machines can capture and analyze images.
Machine vision?
Machine vision.
Wow.
A form of unsupervised learning that involves grouping data points according to features and attributes.
So this is a great question because my advisor has a theory. So Kyung-hyun has a theory that everything is basically clustering or a k-means under the hood. Everything. And I think he has a blog post about it, but I would say k-means or clustering or something related.
Clustering. There you go. And we got to talk about your advisor's work. All right, I'd say perfect scores all around. No, can we share the trophy?
Yes,
Thank you.
let's do it.
Thank you, William. This was really fun, and I appreciate all the help in the game. I'm glad we're on the same team at Grid.